We're about to dig into a huge question about one of the most common drugs on the entire planet. Does metformin actually help your brain, or could it secretly be hurting it? Let's get into the science. So what if a super common diabetes drug, one that's taken by over 150 million people, could either be protecting your brain or maybe harming it? That is the wild debate happening right now around metformin, and we are going to get to the bottom of it.
First up, just the basics. Metformin isn't some brand new experimental thing. It's been a cornerstone of medicine for decades, but it kind of seems to have this secret life when it comes to our brains.
Right, so if you've heard of metformin, you almost certainly know it as the go-to drug for type 2 diabetes. Its main job is pretty simple. It helps control your blood sugar. It does that by making your body more sensitive to its own insulin and by telling your liver, hey, maybe chill out on producing so much extra glucose. It's a real workhorse.
And get this, it's been around for a long time. We're talking first synthesized 100 years ago, way back in 1922. It started being used in France in the 50s. But here's a fun fact. It didn't even get to the US until 1995. And today, the number of people on it is just staggering.
Okay, so now that we've got the background, let's get to the really exciting part of this story. This growing pile of research that suggests metformin might actually be a powerful tool for protecting our brains as we age. This whole brain benefit idea is, well, it's really compelling. Some studies are linking metformin use to a lower risk of Alzheimer's disease. Others suggest it might even improve memory and thinking. And it seems to work right down at the cellular level, helping brain cells use energy better and protecting those tiny, fragile blood vessels that are so crucial for keeping our minds sharp.
Of course, the obvious question is, how? I mean, how on earth can a drug that's designed for blood sugar have these kinds of effects on the brain? Well, scientists are still debating the specifics, but here's what we know so far.
So this is how it seems to work, and honestly, it's fascinating because it goes way beyond just blood sugar. Metformin flips on this critical switch in our cells called AMPK. It's often called a master regulator of our metabolism and is tied to longevity. On top of that, it helps lower chronic inflammation and improves blood flow, all things that are absolutely vital for a healthy brain. Okay, but here's where we have to pump the brakes just a little. It is so important to be clear. The science here is incredibly promising, for sure, but researchers are the first to say this is not yet a proven, done deal. It's a field that's still very much evolving.
But, to get the full picture, we have to look at the other side of the coin, the risks. And as it turns out, there's a really important one that's kind of been hiding in plain sight.
Because here's the paradox, right? While a ton of studies show a benefit, some studies have actually found the exact opposite. They've connected long-term metformin use to worse cognitive performance. And that's the central mystery we need to solve.
So this immediately makes you ask, why? What is going on here? Is the drug itself actually harming our brain cells?
And the answer is pretty surprising. The real culprit, it seems, isn't metformin's direct action at all. Instead, the risk comes from a well-known but often overlooked side effect. The drug can actually mess with your body's ability to absorb vitamin B12. And this is not some rare thing. Some estimates suggest that up to 30%, that's nearly 1 in 3 of people on metformin long-term, might develop a B12 deficiency. And that is a huge deal, because not having enough B12 is directly linked to nerve problems and, you guessed it, cognitive decline. So you've got these two things happening at the exact same time. On one hand, you have the drug's intended good actions, like activating AMPK and fighting inflammation. But on the other track, you have this totally separate indirect side effect, this B12 problem, that could actually cause the very brain issues we're hoping to prevent. So, where does that leave us? When you put it all together, does metformin ultimately help the brain or hurt it? Let's bring it all together for the verdict. The general consensus from the research seems to be this. For most people, the brain benefits appear to outweigh the risks, with one huge if. And that is, if those risks, specifically the B12 issue, are being properly monitored and managed by a doctor.
So who really needs to be paying attention to this whole conversation? Well, obviously, anyone with type 2 diabetes, but also older adults worried about their memory, people with a family history of dementia, and yeah, even that growing community of biohackers who are really into longevity.
Now, with the topic this hot, you know there are going to be some myths flying around, so let's do a quick reality check on the biggest one. So let's just be crystal clear. The myth is that metformin is some kind of magic, brain-boosting smart drug you can take to get an edge. The fact is, while the science is really promising, it's still developing. This is not a smart drug. It's a serious prescription medication, and it absolutely should not be used without a doctor's supervision.
Okay, so with this more complete, nuanced picture, what are the actual takeaways? What should you do?
The expert advice here is really straightforward and, most importantly, safe. Number one, and this is the big one, always talk to your doctor before starting or stopping any medication, period. 2, if you are on metformin long-term, it's a really good idea to ask your doctor about checking your vitamin B12 levels. And 3, never self-medicate with a prescription drug for unproven, off-label uses like brain benefits.
And that leaves us with this final massive question that scientists are racing to answer. If we can figure out how to get all the benefits while managing the risks, could this old, inexpensive diabetes drug actually become one of the first true anti-aging therapies for the human brain? It is a huge question, and only more time and a lot more research will tell us the answer. Thanks for diving into this with us.